All right, welcome to the deep dive. Today we're taking a look at something pretty unique. It's called hell.
Not the fiery underworld kind.
No, definitely not. This is well, you could say it's a different kind of hell, right?
Right.
This hell is actually a shell scripting language, which in itself isn't that unusual, but what makes this one stand out is that it's basically, well, a little piece of Haskell.
Yeah, that's the twist, isn't it?
Yeah, and we've got some excellent material to help us understand it. You've sent over some really neat introductory examples. There's a year in review that digs into how people are using hell in the wild, and then we've got this tour of hell thing, which sounds a bit intimidating, but it's really just a peek under the hood.
Yeah, it gets pretty deep.
So, our mission today is to really grasp what hell is all about. Like, why would someone even create this thing? What problems does it solve that other scripting languages don't? What are its strengths and weaknesses? And ultimately, what makes it such a unique approach to shell scripting? You pointed out that in the intro examples, we see hell doing the usual scripting stuff, like printing hello world
Mhm.
or grabbing some input from the user.
Oh yeah, all the basics are there.
But it also handles files, manipulates lists, can even run external programs.
It's surprisingly versatile, for
Yeah.
sure. And then when you look at that year in review, it becomes clear that people are actually using this for some pretty complex stuff.
Exactly. I mean, generating deployment summaries, triggering notifications, even interacting with APIs like Notion and GitHub.
It's definitely not just for toy projects.
Right. And this tour of hell thing, it gets into the technical nuts and bolts. We'll talk about how it parses Haskell syntax, how it handles type checking without all the baggage of full-blown Haskell, and even how it deals with things like polymorphism and records, which, I'll be honest, those always make my head spin a little.
They're powerful, though.
Oh, definitely. And for listeners who are really into the technical side, who like to understand how things work at a deep level, this deep dive should be a real treat. We'll explore whether this functional approach to scripting, with its roots in Haskell, can actually address some of the frustrations you've probably experienced with more traditional scripting tools like Bash. Okay, let's start at the very beginning. What is this hell in a nutshell?
Well, at its core, Hell is a shell scripting language, but it's kind of a unique beast. It was created by Chris Dunn, and the thing that really sets it apart is that it's built on this like distilled version of Haskell.
Haskell. Okay, so I'm already starting to see why this is different.
Right. So it takes the familiar syntax of Haskell, leverages its standard libraries, and even runs on its runtime system. But it simplifies the whole type safety aspect of Haskell, making it more suitable for scripting tasks.
So it's like taking the best bits of Haskell and making them work for the command line.
Exactly. And by building on Haskell, Hell inherits a really solid foundation. Haskell is well-tested, robust, it's been around for a while.
That makes sense. But what was the whole motivation behind creating a new scripting language in the first place? What problems was the creator trying to solve?
Well, a lot of it stems from frustrations with existing shell languages, especially Bash.
Bash, you mean the one we all use and love to hate?
Yep, that one. The creator mentions issues like Bash's syntax, which can be pretty cryptic.
Oh yeah, I've definitely spent hours deciphering Bash scripts.
Right. And then there's quoting, which is always a headache in Bash, and its reliance on spawning sub-processes for even simple tasks.
Oh yeah, and don't forget the inconsistencies with how Bash handles things like equality, arithmetic, and ordering. It can be really unpredictable.
Exactly. So Hell aims to address these issues by bringing in Haskell's more rigorous approach. For example, in Bash, comparing the string 10 with the number 2 might not give you the expected result.
Yeah, it's like Bash has its own special logic sometimes.
But Hell avoids those kinds of surprises by using Haskell's more principled approach to these fundamental operations.
Okay, so it's trying to bring some sanity to shell scripting. But I'm curious, the creator did acknowledge some of Bash's strengths, right?
Oh, absolutely. The stability of Bash, the fact that it's available on pretty much every Unix-like system out there, those are huge advantages.
Yeah, you can pretty much guarantee that a Bash script will run on any Linux or macOS machine without modification.
Right. And it'll probably keep working for years to come.
That's a good point. So it sounds like Hell is trying to find a balance. When would someone choose Hell over just sticking with good old Bash?
The creator introduces this idea of a scripting threshold.
A scripting threshold. I like that.
Yeah, the idea is that for basic tasks, like running a couple of commands in sequence, Bash is fine. But when things get more complex, like needing to work with more sophisticated data structures, or when you just get tired of battling Bash's quirks and potential for errors, that's when a more general purpose language starts to look really attractive.
So it's like choosing the right tool for the job. You wouldn't use a hammer to screw in a light bulb.
Exactly. And Hell aims to provide that extra power and reliability without adding all the overhead of a full-blown programming language. It's like a precision screwdriver instead of a Swiss Army knife when you need that extra control and accuracy.
Okay, I'm getting a better sense of what hell is and why it exists. But the big question is, why Haskell? It's not exactly the first language that comes to mind for scripting.
Right, that's a great question. And there are a few reasons for that. Firstly, the creator himself is deeply familiar with Haskell. So leveraging his expertise makes sense from a development standpoint.
Makes sense. You want to work with what you know.
Exactly. But more importantly, Haskell brings some real benefits to scripting. Let's talk about equality and ordering, for example. Haskell has a really strict and type-safe way of handling these concepts, which helps avoid those subtle bugs you often get in Bash.
Like when you're not sure if you're comparing strings or numbers.
Exactly. Haskell eliminates that ambiguity, making your scripts more predictable and reliable.
Okay, that's definitely a plus. No more guessing games with types. What other advantages does Haskell bring?
Well, Haskell has a powerful runtime system with built-in support for concurrency, which is a huge advantage for scripting.
Concurrency, so we can do things in parallel.
Exactly. You can have multiple tasks running seemingly simultaneously, like fetching data from multiple sources at the same time. This can make your scripts significantly more efficient.
That's awesome. I can see how that would be really useful for automation.
And then there's garbage collection.
Garbage collection in a shell script. That's a new one.
Right. It might seem strange, but it means you don't have to worry about manually managing memory, which can be a real pain in other languages. Haskell takes care of it for you, so you're less likely to run into memory leaks or other memory-related errors.
So it's like having a self-cleaning script. Nice.
Yeah, it's one less thing to worry about. And Haskell distinguishes between raw bytes and text, which is super important for scripting.
Why is that so important?
Well, when you're working with data from different sources, especially when it comes to things like files and network connections, you can run into all sorts of issues with character encodings. Haskell helps avoid those headaches by making it very clear what you're dealing with.
So no more weird characters messing up your scripts. That's a relief.
Plus, Haskell can be compiled into self-contained executables, which makes deployment a breeze. And of course, there's static typing.
Ah, static typing. I know that's a big deal in Haskell, but how does it work in a scripting context?
Even though Hell's type system is simpler than full Haskell's, it still provides that safety net of catching type errors before you run your script. You can use the check flag to run the type checker, which can save you a ton of time, especially when you're dealing with long-running tasks. It's like having a spell checker for your code.
Okay, I'm starting to see the appeal of using Haskell for scripting. So let's dig into the language itself. What are some of the core features that stood out from the material you sent?
Well, first off, the syntax is very similar to Haskell, so if you're already familiar with Haskell, you'll feel right at home.
That's always good. Less learning curve.
Right. But there's no module system like you have in full Haskell.
No modules. How does that work?
Well, instead of importing modules, you refer to functions by their fully qualified names. So instead of just lookup, you'd write list.lookup. Same for other functions like async.race. This keeps the language lean and focused, and it avoids all the complexities of dependency management.
So no more dependency hell in hell. Ironic.
Exactly. Another interesting thing is that there's no direct support for recursion.
Recursion, as in functions calling themselves.
Yes. You can't define a recursive function directly, but Hell provides a special function called fix that lets you achieve recursion in a slightly different way.
That's clever. So what about those more advanced Haskell concepts, like type classes?
Hell supports a few essential type classes like EQ, ORD, show, and monad.
I vaguely remember those from my Haskell days. Can you give me a quick refresher?
Sure, EQ lets you check if two values are equal. ORD is for comparing and ordering values. Show allows you to convert values into strings for display, and monad is a bit more abstract, but it underpins a lot of Haskell's power, including input-output operations.
Okay, so that rings a bell. So are those enough to work with Hell's standard library?
Oh, absolutely.
Yeah.
For example, list.lookup uses the EQ-type class to compare keys when searching for a value in a list. Initially, Hell didn't support polytypes, which are functions that can work with different types, but later editions included type inference, record types, and sum types.
I'm sensing a theme here. It seems like Hell started with a minimal set of features and gradually added more over time.
Yeah, that's a good observation. It's like they wanted to keep the core language small and manageable, but also recognize the need for more expressiveness as people started using it for more complex tasks.
That makes sense. So what about concurrency? We saw those primitives like async.concurrently and async.race in the examples.
Right, those come straight from Haskell's concurrency features. Hell lets you work with text, manipulate lists, handle input and output, manage files and directories, access environment variables, and of course run other programs. It even has tuples, booleans, and if-then-else statements, just like you'd expect in a scripting language.
Wow, so it really does cover a lot of ground for a small dialect.
Yeah.
The year in review really drove home how people are using it in real-world scenarios. Those deployment summaries, the notifications, even importing data from APIs, that's pretty impressive.
It is. And the fact that the creator mentioned his colleagues are using it too suggests that it's not just a personal project. It's actually solving real problems for people.
Right, it's got to be more than just a fun experiment to gain that kind of traction. And the performance seems to be up to par as well.
Yeah, from what the creator described, the performance is comparable to GHCI, the Haskell interpreter. He considers that fast enough for most scripting tasks. He also emphasized that most of the time, the bottleneck isn't the scripting language itself, but rather the external programs you're running or the data you're transferring.
So it's like as long as the scripting language isn't adding a significant overhead, you're good.
Exactly. The year review also mentioned the benefits of using data structures like map and set. That's a big deal for scripting.
Why is that? I mean, what's wrong with just using arrays or lists?
Well, in traditional shell scripting, you often end up representing data in ways that aren't very structured. You might use strings or arrays of strings to store data that really should be organized as key value pairs or sets of unique items.
Right, I've seen some pretty messy shell scripts in my time.
Exactly. It can get really hard to reason about and maintain those scripts. But Hell provides access to these well-defined data structures like map and set directly from Haskell's standard library.
So you can write cleaner, more maintainable scripts.
Exactly. And it's much less error-prone.
Okay, I'm starting to see the light. So let's talk about ergonomics. How easy is Hell to actually use, especially for someone coming from a Haskell background?
If you know Haskell, the learning curve is pretty minimal. The syntax is familiar, and the creator mentioned that you only really need to keep a small set of API functions in mind when writing scripts.
That's always nice. Makes it easier to focus.
Right. And he even found that colleagues who were new to Haskell but had some programming experience could pick up Hell relatively easily.
So it's not just a language for Haskell experts.
No, it's designed to be approachable for anyone with some programming experience. And the check flag for type checking is a great ergonomic feature. It gives you instant feedback on potential errors before you even run your script.
It's like a safety net.
Exactly. And the creator mentioned that he uses tools to automatically rerun the type checker whenever he saves his script, which makes the development process even smoother.
That's slick. So the creator also talked about the low risk associated with adopting Hell. What makes it so low risk?
The close ties to Haskell are key here, because Hell is essentially a subset of Haskell. Any Hell script can theoretically be translated into full Haskell code.
So if Hell ever gets abandoned, you can still port your scripts to Haskell.
Precisely. It's a nice insurance policy. Plus, if a Hell script ever becomes a performance bottleneck, you can always rewrite it in Haskell and compile it for maximum speed.
So it's like having a performance escape hatch.
Exactly. And the language itself is designed to avoid breaking changes, which is crucial for long-term stability.
How do they ensure that?
The creator mentioned a couple of strategies. First, he's willing to accept some minor imperfections in the language rather than introducing breaking changes. Second, Hell relies heavily on Haskell's standard libraries, which are already quite stable. And finally, you can use standard Haskell code formatters on Hell code, which ensures consistency and readability.
So they've really thought about long-term maintainability. All right, let's flip the coin now. What are some of Hell's weaknesses or limitations?
One major drawback right now is the lack of dedicated editor support.
So no syntax highlighting or auto-completion in your favorite editor.
Well, the creator made an Emacs module for personal use, but that's about it. It's a barrier to wider adoption, because good editor integration can make a huge difference in productivity and error prevention.
I see your point. Anything else?
Yeah, the error messages, especially for type errors, could be more informative.
So they might tell you where the error is, but not necessarily why.
Right. It can take some digging to figure out the root cause. The creator acknowledges this and plans to improve them.
Okay, that's good to know. Now let's get into the technical nitty-gritty. The tour of hell gave us a peek under the hood. What did we learn about how this thing is actually implemented?
It's quite fascinating. For parsing the Haskell syntax, Hell initially used a library called Haskell RCX, but the plan is to eventually switch to GHC's parser.
GHC being the main Haskell compiler.
Right. This would make Hell even more closely aligned with standard Haskell and allow it to support newer language features more easily. After parsing, there's a desugaring phase, where complex syntactic constructs are simplified.
Desugaring. Sounds sweet. What's that all about?
Essentially, it's a way to transform the code into a more fundamental representation that's easier for the rest of the implementation to handle. For example, Haskell's do notation, which is used for working with monads, gets translated into a simpler form.
So it's like breaking down complex expressions into smaller, more manageable pieces.
Exactly. And the core of Hell, the part that actually executes the code, is designed to be lean and total.
Total, as in it always produces a result.
Right. It's guaranteed not to crash unexpectedly. The implementation draws inspiration from Oleg Kislyov's work on typed tagless final interpreters.
Those are some serious programming concepts.
They are, but they result in a very robust and predictable execution engine. It uses an environment-based evaluator, and variables are represented using a technique called De Bruijn indices.
De Bruijn indices. Now that sounds intimidating.
It's actually quite elegant. It's a way of referring to variables by their position relative to where they're defined, rather than by their name.
So it avoids those nasty issues with variable shadowing.
Exactly. It makes the language's internal workings much cleaner and less prone to errors.
Okay, I'm starting to appreciate the level of engineering that went into this. So how about the type checker? How does Hell handle that without the full complexity of Haskell's type system?
The design of the type checker was heavily influenced by Stephanie Weirich's work in type theory. It takes the untyped Hell code and tries to figure out the type of each expression.
So make sure you're not trying to add a string to a number, for example.
Precisely. And it produces a typed version of your code, where every expression has an associated type. The type checker also keeps track of variable scopes using a typed environment.
So it's like a detective figuring out the types of everything and making sure it all makes sense.
That's a good analogy. And to handle those basic type classes like EQ and ORD, Hell uses a clever technique inspired by Ikan Chatov's research.
What's the trick?
Well, it infers the necessary implementations for those type classes based on the types it already knows about in your program. This way, it can support things like comparing values for equality or ordering them without needing the full power of Haskell's type class system.
So it's a more streamlined approach tailored for Hell's specific needs.
Exactly. And to implement records, which are like named collections of data, Hell uses GADTs, or generalized algebraic data types.
GADTs, I've heard those are pretty powerful.
They are. The type of a GADT encodes information about its structure. In Hell's case, the type of a record encodes the names and types of its fields.
So the type system knows what kind of data you can store in each field of a record.
Right. And to make things even safer, Hell automatically generates type-safe accessors for records.
Accessors, you mean functions to get and set the fields of a record?
Yes, and it does this using Haskell's type reflection feature, which is quite advanced. This guarantees that when you access a field of a record, you'll always get the correct type of data.
That's a really clever way to ensure type safety. It sounds like they've put a lot of effort into making Hell both user-friendly and rock-solid internally. That front-loaded compiler design, where most of the work happens up front, is an interesting choice.
It is. The goal was to have a very efficient execution engine once all the initial processing is done. The whole pipeline involves parsing, desugaring, type inference, type checking, and finally, execution.
Sounds like a well-oiled machine.
Yeah, the creator has a clear vision for how it all works. And there are plans for future improvements, like better error messages, migrating to GHC's parser, a more efficient type inference algorithm, and maybe even adding support for some types and a case syntax.
So Hell is still evolving. Well, this has been an incredibly deep dive into a very unique language. For our listeners who are all about gaining knowledge quickly and thoroughly, what are the key takeaways from our discussion today?
I think the biggest takeaway is that Hell offers a genuinely new and exciting approach to shell scripting. It brings the rigor and power of Haskell to a domain that's often characterized by, well, let's just say, less elegant solutions.
To put it mildly.
Right. And it does so without overwhelming you with the full complexity of Haskell. The examples we looked at show that it's practical for everyday scripting tasks, and the year in review demonstrates that it can handle real-world challenges. For those of you who appreciate a well-engineered solution and who are perhaps a bit frustrated with the limitations of traditional scripting languages, Hell is definitely worth exploring.
And to leave our listeners with a final thought, what's one thing they should ponder after this deep dive?
The tour of Hell gave us a glimpse into the technical brilliance behind this project. How it handles type checking and data structures with such a small and efficient implementation is truly remarkable. If you're interested in the intersection of functional programming and language design, or if you've ever felt the pain of trying to write complex logic in Bash or other shell languages, I encourage you to dig deeper into some of the concepts we discussed today. Things like de Bruijn indices or JDTs might seem daunting at first, but they're fascinating examples of how clever engineering can solve real-world problems. And who knows, maybe this Haskell-inspired approach is the future of automation.
Plenty to think about there. Thanks for joining me on this deep dive into Hell. Until next time.
It's been a pleasure.
Take